Okay, good afternoon, everyone. Thank you for joining us this afternoon. We're very fortunate to be joined by Dr. Lynn Bowie this afternoon in our first Neo Series Educator session for the year, where essentially the goal of these sessions is just to connect across the educational landscape, specifically in maths education, and learn and share from one another. And hopefully the learnings are very applicable in a number of circumstances. And hopefully the networks that generate out of these sessions are also useful in furthering our impacts as educators. The reality is that we live in a context where the number of skilled educators is dwindling in comparison to the demand. And so the more that we can leverage our skills, share our skills, the better off the system will be for it. So, like I mentioned, we are very fortunate to have Dr. Lynn Bowie on this afternoon. Just as a brief introduction, Dr. Bowie is the Director of Mathematics at OLICO Mathematics Education and a Research Associate at the University of the Witwatersrand. A passionate advocate for educational equity, she is committed to transforming maths education in South Africa. At OLICO, Dr. Bowie leads the development of innovative evidence-based approaches that help learners build strong mathematical foundations. Her work bridges research and practice to tackle systemic challenges and improve outcomes in under-resourced communities. We've been fortunate to work with Lynn and Celeste at OLICO and their team at OLICO over the past 2 years, collaborating in the further studies maths domain. And I just felt it would be so beneficial for all of us to hear of the work that Lynn and her team are doing at OLICO, and the research that she's done over the many years of research at WITS. So without further ado, if that's the correct expression, it always confuses me, that one. I'd like to hand over to Lynn to take us through her keynotes. Thanks, Lynn.
Great. Thanks, Chris, and thanks everybody for joining in a month that is, I think, for most of us in schools, proving to be quite a sort of disrupted stop-start month of everything. So thank you for being here, and I really look forward to chatting with all of you. And just to say, to Chris, we've had a fantastic collaboration with Advantage Learn, and I'll talk a little bit about what's happened in that space as we get into the talk. So my career in maths education has spanned really the entire kind of grade levels. My first job was as a lecturer in pure mathematics at UCT, and I slowly started moving backwards from there in terms of the grades. So then started working with high schools, then started working with primary schools, then started working with really low level in the primary schools and also with grade R. And so at this stage in OLICO, we work all the way through from grade R through to working at universities with teacher training. And that kind of the privilege of having had those experiences across the entire grade span has actually given me some insights into things that I think are worth sharing and discussing, and I hope that you will find them worth hearing about. Before I launch into it, and I'll give you a little more info about OLICO and what I'm going to be talking about today, I just want to kind of remind us of the context. I think we all know it really well, but I think it's an important one to just every now and then revisit. So let me try and get myself onto my next slide. And of course now, there. So the context is, one we know really well, which is that although there's reasonable pass rate in mathematics, if you're looking at 30% as your pass mark, the minute you get to quality passes, the kind of passes that will enable learners to do something with their maths, so sort of 60% and above, you're talking about very, very small percentages of our learners achieving that. And if you actually look at the kind of 80% plus pass rate, it's, you know, of the order of 3% of our learners who do maths are able to pass at that level. And then in combination with that, what we've seen over the last while is declining participation rates in mathematics. So a move to maths literacy, and now an increasing move also into the technical maths. And so kind of leaving maths to, at this point, around 32% of our learners only in matric doing maths. And this scenario is not surprising if you consider what we know happens across the bands of schooling. So this is a very interesting piece of research that was done by Spall and Kotzer, and they used various systemic and international tests to estimate how far behind our learners in quintile 1 to 4 schools are behind our learners in quintile 5 schools. So our quintile 5 schools, those would be your well-off schools, you know, in your well-off areas, and the quintile 1 to 3 schools are your no-fee schools. And what one sees in this picture is that right from the start, from grade 3, your learners in quintile 1 to 3 schools are at least 2 years behind where they should be. And by the time you get to grade 9, that gap has increased to about 4 grade levels. And that's the scenario that we face in our schools. And I'm sure that many of you online today have that experience of learners coming to your high schools who actually are nowhere close to the level that they need to be. And that's certainly in the kind of schools that we as OLICO work in, the experience that we have. And so to give you a little bit of background then into OLICO is because we've seen this problem exists, and it exists right from primary all the way through, our programs that we work with go all the way through too. So for primary schools, we have what we call maths clubs, where we work after school with learners from grade R through to grade 6. And there they work in small groups, often with youth facilitators, who then in those groups play maths games, work on maths ideas and basic number skills with our learners so that they actually get the basics in place that they need to succeed. The bit I'm going to focus on more today, or the experiences I'm drawing from more today, is the work we've done in senior phase maths. And there we work primarily in township schools, and we use a combination of technology and tutors in order to work with learners in grade 8 and grade 9. And here I'm going to speak particularly to some of the lessons we've learned from that, and particularly working with learners who need to get to a point where they can take pure mathematics in grade 10, but are often far behind where they should be when they come in at grade 8. And then just to tell you a few of our success stories, learners can start in grade 8 and 9 many years behind where they should be. And with the kind of dedication and work and working with the really wonderful tutors that we have, who are all young people themselves, young people who are really good at maths, people can actually achieve and grow. And so one of our wonderful success stories is this Kelebogile, who is from Diepsloot and was in the top 20 matrics in the country in 2023, I think it was. And then to pick up a little bit on the story that then is one of our more recent projects, is having seen that there were a number of our learners who actually really were succeeding at maths and doing well at maths. We also wanted to open opportunities to them that are traditionally only available to learners at private schools or at the well-off government schools. And that's where we approached Advantage Learn about trying to see whether we could get some of our learners to work on further study to maths through the Advantage Learn program. And last year, our first matriculant came through with 70% for further studies maths, which we were really chuffed about. And it's something that we really feel quite passionate about and want to grow this program. It's hard. It's really hard for the learners to do, because they have to, you know, they don't, they have to kind of essentially be studying it on their own through the online platform. And that takes a lot of dedication. And there are often only one or two of them in their school who are doing it. But I think that it is incredibly important for learners who want to go on to university to study maths, so that when they arrive at university, they're able to move into the kind of university maths, succeed at it, and not always feel slightly on the back foot. So we're very excited about this program and keen to figure out ways to make it work. It's tough though, you know. I think it's really hard. You know, our learners, and it's one of my big concerns, that matric has become, especially in township schools, such a sort of hothouse environment. Learners are kept at school 6 days a week from, you know, 8 in the morning till 8 at night, and cross-nighting, which means they sleep at the schools and stuff, which really doesn't strike me as the kind of sort of holistic and helpful education that we want. It feels like a cram school. So trying to fit in extending yourself and really learning something new like further studies maths is quite hard in that context. Okay, so that gives you a little bit of background into who I am and what we do as OLICO. And I think that really then to sort of tell you where I'm going to go to with this is to say, well, for the last good 12 years, I've essentially been very involved with working with our learners in mostly in primary school and senior phase. And what has that taught me, and what are some of the lessons that I've started to draw out from that in terms of what we might be wanting to do moving into high schools, and what we might need to do to help bridge that gap for learners coming into high school? The main theme of what I'm going to talk about is that our learners do have backlogs. They're far behind in a number of things. And with the way in which we want to work on that is to create connections and coherence for our learners through representations, through language, and through ways of working. And I'll come back to those themes throughout. But to start off, there's one very clear thing for me that we need to actually have as part of our high school program. And that is a very strong focus on mental mathematics. It doesn't have to be a massive amount of time, but it does have to be something that our learners get on top of. And this has just been through my experience of every grade 8 classroom that I've entered. I see many of our learners, the backlogs they have are not grade 7 or grade 6 level maths. It's often far further back than that. That many of our learners are coming into grade 8, still doing their calculations, simple addition, by either using their fingers or drawing little stripes on paper. So basically using counting to do it. That learners in grade 8, for some of them, it's not immediately obvious that 43 plus 10 is 53, or that 30 plus 6 is 36. And multiplication and division are particularly problematic. And for me, making sure that our learners actually do have the capacity to do simple calculations in their heads is a really important one. And that is, from a very sort of my simplistic understanding of cognitive load theory, it's if you're spending all your time doing your calculation by counting up on your fingers, there is no space left for you to actually think about the kind of algebra that you're being asked to do, or to worry about what like terms might be if actually when you have to do 5x plus 3x, you've got to go 5, 6, 7, 8 in order to get the answer. So it's certainly been something that we've seen as very important. And you'll see my proposal there is basic addition, subtraction, multiplication, and division should be something that we make sure all our learners are very fluent in. And then there are also some other things that I think for our grade 8s and 9s are important. Squares, cubes, cube roots, square roots, knowing them, just knowing them off by heart, basically, is really important. So one of the things that we've worked quite a lot on is trying to find mechanisms to enable this to happen, learners to get on top of it, but without it taking enormous amounts of time. So the app that we have created is called the Mental Maths Minute, and it takes learners through a series of levels, starting right from very simple addition under 5, subtraction under 5, addition under 10, subtraction under 10, and moving all the way through to 2-digit addition and subtraction. So that app is freely available on the Google Play Store, and it's currently in beta version. So if you do try it out, do give us any feedback. We also have an online version. If anybody wants to, they can just get hold of me and I can give you access to it. The idea of this is to get our learners fluent. So to put them on for 5 or 10 minutes every day to get them fluent in their calculation, so that doesn't become part of what we need to work on with them. But here now we get also to some of those connections and coherence that I'm talking about and images that we want our learners to have. So if you look at this sort of one string of what we work on in the Mental Maths Minute, it is really that idea of the repeating patterns within 10. That there are not, if you know 2 plus 3 is 5, 22 plus 3 is 25, right? You also know that 20 plus 30 is 50. Those kind of connections that we want our learners to have. And so giving them images like either the 100 chart or a number line, divided so that that repeating pattern in 10 is shown, is part of what one then needs to do. These are things that we've kind of taken out of primary and brought into our grade 8 classes so that learners who haven't had that experience and haven't seen the connection into those repeating patterns in 10 are able to get on top of that and then drill it through the app in order for it to become fluent. But there are also other aspects that we work on in number that we think have very important, and they are important not only for their calculation fluency, but also for their ability to connect through and cohere through into the work they need in higher grades. So let me show you what I mean. One of the things that we work on is subtraction as difference. In other words, if you want to do a calculation like 52 minus 48, the easiest way to do it is to say, how far is it from 48 to 52? The answer is 4. 104 minus 99, how far is it from 99 to 104? The answer is 5, rather than doing subtraction as take away. And the image we use for learners for that is a kind of number line image that you can see. There's 144. There, if you take away that 99 ribbon, you're just left with the gap between 99 and 104. And that kind of image of subtraction is important, and the work with number lines is important. And let me show you why. This is where this kind of theme for me of connections and coherence through representations becomes important. If you see subtraction as difference here, you can see 73 minus 48, for example, is that red strip. But it's also, if you just move that red strip forward, you can see that it's also equal to 75 minus 50. So you're starting to get some images in your head of subtraction as the gap between two things and equal distance. And so this then can move you into some of your algebra ideas, so that x minus y is the same as x plus 1 minus y plus 1. Working with those kind of ideas on the number line is important. I discovered, for example, that many of our learners, when I was sort of working with them to do some work in negative numbers, and ask them, you know, if you go 5 subtract 8, where will you end up? And they could only do it by counting back in ones on the number line. And I was like, but if you go from 5 down to 0, how many steps have you gone? And a number of learners in the grade 8 class could not tell me automatically that moving from 5 down to 0 is a space of 5. And then from 0 down 3 steps will end you at -3. So quite powerfully, their kind of understanding of the number line and therefore axes was very, very limited and did not have a good sense of number as distance on the number line. And the reason why I would argue those kind of things are important is at some point, if you're going to continue through to matric, you're going to have all these questions about what's the length of MN there. And if you've got no sense of how that the number line works and distance on the number line works, this is not going to be something that's going to make any sense to you. And funnily enough, it was something I saw over and over again when I was lecturing first year maths, that was a real hindrance to a number of our learners. So what I'm arguing in terms of this connections and coherence is if in the way we work with our learners with number, we work with them in powerful ways and with powerful representations that then move through and can stay with them through the rest of their maths career. You've got something they've got, by the time they're starting to deal with those kind of length of lines in functions in matric, they've got a strong enough understanding of subtraction as difference, length on the number line, etc., to be able to make sense of it. It's not something totally new. All right. I wanted to play you this, but I couldn't get the sound working nicely. It's just a little emphasis on my part that times table fluency is utterly crucial. And this is one of our very energetic tutors, and he has a wonderful rhyme that he does with the learners to get them just practicing and chanting their times tables. And I know for many people that might be very old-fashioned and, oh my goodness, do we really need to do it? My argument would be we absolutely do. Our learners need to know their times tables. No doubt about it. You cannot start and make sense of or easily work with factorizing quadratics if you don't have your times tables absolutely firmly bedded down. And so for me, whichever way and however we can, we need to get our learners on top of their times tables. So again, we've got the little app which we work with getting our learners fluent on their times tables. We have a times table competition. We have beautiful songs and chants. There are some lovely games that you can play and that we do play with learners or send them home with that just work on multiplication and division with them. So here's one for you, and it's 1 to 20 here, but you can do it with 1 to 50 or whatever. If we were in person, I'd make you play it now, but it's hard to do that online. But let me explain it to you, and I promise you try it at some point, and you'll see it's actually a lot of fun. So basically, you play against a partner, and what you're doing is you're crossing off numbers. So the rules are the first number must be even. So let's say I choose to cross off 6. It's now Chris's turn, and he must cross off a multiple or a factor of the number I've just crossed off. So he could cross off 12 or 18 or 3. Let's say he chooses to cross off 3, a factor. My turn now, I must cross off a multiple or factor of the previous number, right? So I could cross off 1, or I could cross off 9. I can't cross off 6, it's already crossed off. Could cross off 12, 15, etc. And you carry on like that. And the first person, you win if you make it so that your partner has nothing to cross off. So it's a constant practice of factors and multiples, your times tables, and it's generally great fun to play, but just allows one to practice your times tables. Similarly, we've got games like target times table, where we give the learners a target. This can be played in 2 minutes at the start of class. Here's a target. Think of which of your times tables will get you as close to that target as possible. By times tables, I mean anything from 1 times 1 to 12 times 12. And learners have to come up with that quickly. So just little things to keep our learners' knowledge of their times tables alive. But it isn't only the drill stuff. The idea of multiplicative reasoning is an absolutely crucial and important one. So this kind of story here, Mr. Short and Mr. Tall, is a very sort of famous piece of research that's been done many times. But the story is that, Mr. Short, you can see he's 6 paper clips tall. Mr. Short is also 4 matchsticks tall, and Mr. Tall is 6 matchsticks tall. So if we now want to know how tall is Mr. Tall in paper clips, the idea that you're asking learners to work with there is an idea of proportion. But if you try it out with learners, the vast majority of learners at around the grade 6-7 level will continue to use additive reasoning and simply tell you that Mr. Tall is 8 paper clips, right? Because you've added on 2 matchsticks, you must add on 2 paper clips. So that idea of multiplicative reasoning, proportional reasoning, is something that is quite hard for learners. It's a move that learners need to make, and it's something that that our learners should be making. It should be a priority in our intermediate phase teaching. But you will see that often learners coming into the senior phase haven't fully got on top of their multiplicative reasoning and still default to additive reasoning. So actually understanding multiplication and division become really important. So I'm going to just go through a little bit of talking about how one might understand multiplication and division in a way that actually levers up something for algebra at high school. If you look at an activity like this, at primary school, a lot of the time we're asking learners just to give you the answer. They must do the calculation, right? Whereas what you want to get to at high school in preparation for algebra is for them to be comfortable leaving unfinished calculations and being able to be happy with things like statements of equivalence, like 88 times 99 is the same as 8 times 100 minus 1. And hopefully you can see that the kind of things and ideas that I'm trying to get across in this table in working with learners is these kind of equivalents and ways in which the multiplication, the ideas of multiplication you can work with your numbers can then extend into algebra. And one of the ways that I argue that you can make that move into high school maths quite powerful is if you use representations that bridge that gap between the numbers and the algebra. So if you think here, I mean, here's a simple statement. 9 times 13 is 10 times 13 minus 13, right? Which is 130 minus 13. If you see it here, right, there is, you'll just have to believe me that there are 13 blocks in every row unless you want to count it quickly, but there are 10 times 13 blocks in what you see there, right? If you want to get to 9 times 13 blocks, you simply have to take off this final row of 13. So 9 times 13 is the full lot of 10 times 13, taking off the 1 times 13. And you can then start to kind of more generalize that into 10 times whatever, 9 times whatever you want it to be, whatever length you want it to be, is the same as 10 times the length minus the length. And this notion of multiplication and the idea of length is a very powerful one to then extend into your metaphor for variables. Because if you then start to see your x as a length and your y as a length. If you look here, my one block is a length of x plus a length of y. If I've got 3 of those, then I've got 3 lengths of x plus y, but I can also see it as I've got 3 x's and 3 y's. So this idea that we can move through from our work on number to our work on algebra and keep that same metaphor, that same representation, is a powerful one and allows those sort of links to be made by our learners. Another metaphor that I find quite useful here is the metaphor of a bag or a sack, right? So what is 9 times 13? It's 9 sacks with 13 sweets or whatever in each sack. So if you start with 10 sacks with 13 sweets in each, and then you take one of those sacks of 13 away, you're left with 9 sacks of 13. Hopefully you can see quite easily how that metaphor also extends very well to algebra. You could very much talk about what's 10x minus x. Well, 10x is 10 sacks, each having x sweets in them. And then you take one of those sacks with x sweets in, and you're left with 9 sacks with x sweets. So you start to then be able to, at some point, be able to give a more concrete representation of your algebraic ideas with kind of sacks containing x sweets, and then the little sweets being individual sweets. And so my argument is that if we use powerful representations that can connect number into algebra and can give our learners a more concrete feel for algebra, then we have more chance of allowing them to bridge into algebra at high school. So for me, the metaphor of for variable of a length or of a sack containing a certain number of sweets are powerful ones that we can use to help our learners understand algebra. So you can see, for example, why if you have a bag that has X sweets, two bags that have X sweets and another bag that has Y sweets, you can't just say that's X, X, Y, right? You start to see why you need to have like terms in order to add. So you're giving some form of concreteness to the ideas for the learners. In a similar way, we want our learners to have a very robust sense of division. And we need them to understand division in both ways, division as sharing and division as grouping. And sharing means 12 divided by 3, 12 sweets shared between 3 children. And grouping means 12 sweets, and I want to put them in packs of 3. So how many packs of 3 are there in 12? Why do we need our learners to have both of those? Well, if we're going to have them go into working with either fraction division or any kind of work with more sort of generalized work with division, we need that idea. So, for example, the division as sharing idea is very powerful for understanding if I've got one cake shared between a big group of people, everybody's going to get a really small piece. So 1 over a big number is a really small number. The idea of how many groups of 2 are there in 6 is a more important way of understanding division if you want to ask, give a meaning to 5 divided by half. How many halves are there in 5? Now, I'm conscious of my time, so if I have time, I'll come back to this one. It's one of my favorite examples, but I want to just tie up some of the stuff that I've been talking about. So what I'm trying to say is that if we want our learners to move from number into algebra in high school in a way that works, we need to create the links for them, the move for them between the concrete and the more abstract. In some ways, we're going to use representations to do it. So for me, the number line is a particularly powerful representation that allows us to do things in number that can then have powerful spillovers into algebra, but also obviously has powerful spillovers into when we introduce the Cartesian plane and understanding work on the Cartesian plane. The other idea is some form of a representation like a bar model, like a length thing, that is powerful for work in number, but can also be very powerful for work in algebra. And there's just a very simple example of, here's the distributive law for number, and there's the distributive law for algebra. Using the same representation, one can start to see those ideas connect across. The last thing I want to kind of talk about a little bit today is that what we need to make sure we do at the start of high school is the way in which we work with number needs to be in the way that is most optimal for carrying it through. So say, for example, multiplying fractions. I know that most kids seem to be taught at primary school, multiply the numerators, multiply the denominators. They do that, and then they get the answer, and then they try and simplify the fraction. If you think about where our learners are going to go to in high school, that's not what we want them to do. We want them to do this sort of thing, where you write it like this, right? And you don't go to here. At this stage, you start to look for where you have your common factors that you can divide out, because that's precisely what you're going to do when you get to the algebraic form of it. And so although this might feel a bit more effort and work to work on with learners now, it's actually worth it because it's what they need. It's the kind of way in which they need to work with fractions when they get to algebra. And one of the things I learned really recently from an Australian primary school mathematics teacher is think very carefully about the language you use so that those connections can be made for learners. So you need to almost, and that I think is one of the ways we can help our learners, is to give them ways to talk about things, certain key phrases that allow them to make links as they go. So for example, if when I am teaching them the routine for multiplying fractions with numbers, right? I can give them, and I haven't thought beautifully about the words, but let me go, multiply the numerators, multiply the denominators, but don't evaluate. Then divide numerator and denominator by the same factors. That's going to be the routine, the words, the phrases I use over and over when I'm talking about how to do multiplication of fractions with numbers. When I come to doing algebraic fractions, I'm going to tell them those exact same words. Remember, guys, we're going to multiply numerator and denominator, but we're not going to simplify it, work it out. Then we're going to see what factors can divide in top and bottom. So you've got the same language creating the coherence between your number and your algebra. And then the last little example of this kind of thing that I want to give you is, ratio and rate, I never knew, but there's a ratio and rate I believe you just meant to do by cross multiply. And I've never really understood cross multiply. It was, it's just a quick thing. You cross multiply and you can sort out any ratio and rate. I think it's worth spending a little bit more time really understanding ratio and rate in the younger years so that it actually coheres all the way through. Because if you look at this kind of T-table idea for ratio and rate, where you can look at, well, what do I multiply this by? What do I multiply this by? How does dividing this by this and this by this? All those patterns you can see in that sort of T-table for ratio and rate. Well, that's exactly what happens when you talk about slope. And it's exactly what happens when you get to trig in your FET phase. So if we can work with the same idea powerfully throughout our learners' trajectory, it isn't, maths then no longer becomes about 1,000 little disparate pieces of knowledge that somehow we have to keep juggling in our head. So I was going to go on to a whole lot of stuff around geometry, but as I said to Chris, I always overestimate how fast I'm going to talk and get through things. So I'm going to stop there on the algebra and just say that really what I've been trying to talk about is if we want to bridge the gap for learners, we need to help them move from where they've been working in the more concrete work with number to the more abstract work with algebra. But if we want to do that, we need to really work on the connections and coherence. And some of the ways in which we can do that is by thinking very carefully about some core representations we can use that work powerfully throughout, thinking about the kind of language we can use that can make those connections and make them cohere for our learners, and also about the ways in which we work. So the way in which we work with fraction multiplication when we're just working with numbers is a good way, which will also work when they get to working with it with algebra, so they don't end up being seen as two totally different things. And I think that I'll leave that there for now, and hopefully open up some time for discussion.
Amazing, thank you, Lynn. I'm looking through the remaining 6 slides or something that you have, and I'm feeling like we're missing out on the remaining 6 slides because you got some great stuff there as well. But I do think it's wise to enable some question and answer. It's been fascinating to listen to you and your take on these things. Thank you so much. Yeah, so the floor is open to questions at this stage. Maybe I'll lead off on one. Is I think maybe to end with is you know, I love the way you've explained these concepts. The one saying, I don't know where it came from. Maybe I came up with it, but I doubt it. Is if you can see maths, you can do maths. You know, if you can get a visual understanding of maths, you can do it. And that's why in the later grades, you know, I love functions and plotting graphs, and because you can get a sense for the trajectory of the numbers and how they behave. And when you can see it in your mind, then all of a sudden things make a lot more sense than just cranking out some algebra, because you know the rules of the algebraic expressions. But I think that as you ended off there, the one thing I thought to myself was, you know, there's a persistent theme in maths where educators feel like the syllabus is quite large, and we need to get through the syllabus, you know. And so these exercises, these visual exercises that you're talking about, it's often a dilemma of it might add value, but how long is it going to take in the classroom, you know? And I need to get through the syllabus. So I don't know if you have any thoughts in that regard, and because I think that's a consideration sometimes. People don't want to go do these exploratory manipulatives too much because they're worried about the time factor. What would you say to that?
I mean, absolutely. I mean, that is always an issue. The time factor, I get it. And I think that in many of our schools, it's actually, you know, got to the point of ridiculous in terms of teachers being pushed to move even when they know their learners are not with them. I mean, that just, you know, doesn't work for me. Certainly a number of us have been arguing, I'm not sure if it's going to get heard, that the senior phase curriculum is too full, too repetitive, you know, too much there to really give the time for it, and needs to be rethought in a way that allows for more of that time. And we're supposedly getting a strengthened curriculum arriving next year, you know, who knows? And hopefully some of those ideas might have been taken on board. But I think if your school in any way has the ability to maneuver a bit within the kind of curriculum and ATP or whatever, it's entirely possible. You know, if you look at it, you can actually take time out in grade 8. You know, you do Pythagoras in grade 8 and in grade 9. surely there's a way in which you can do something far more exploratory in grade 8 that builds into grade 9. You do, there is space, and I think it is worth the time. And that's also where I think if we think, and it takes a while to get this right. I think if we do it very carefully, we can also save time by making the connections. So if we get teaching fraction multiplication with number right and can connect it quite quickly to the algebra, we'll save time in the future. But it requires creating very coherent material and working across the grades, not just within your grade.
Yeah, I'm completely with you, and love that take on it. By taking time earlier, it pays dividends in saving times later because you've built the understanding. And I don't know what sections Trish talks about in the senior phase. She has a similar message. It's like, don't worry about these sections because they will pick these sections up quickly when they are ready to pick them up. But you got to get these sections right. You got to get this right. And so I think it's a good message. And I know a lot of young teachers, they want to do right by the syllabus. They want to make sure they get through everything and all of that. And I can understand that. But to your point, I think it's so important to get to identify what are the most important things that we're trying to teach in this grade, and make sure that we get those right, because pushing forward in a syllabus when no one's with you is, like you say, pointless. Thank you.
Yeah.
I want to invite questions from the forum. You can also put your hand up, and I can put on your voice channel if you have anything. Celeste, I see your chat there. One of our main messages that OLICO is making maths make sense. Yeah, I love that. That's brilliant. The other thing, Lynn, I think is on these manipulatives is that they might seem like they take long. Well, then you might feel like it might take long, but if you actually just have a set of manipulatives that you can pull on for certain sections, they probably don't take that long. Maybe the first year that you actually use them in your setting, you figure out how to pitch it with the learners. But in the second year, you know which tools you're going to use, which settings, and actually it doesn't take too long to work with them, with the learners.
And one of the things that I often do with the learners as well is because, we don't want to leave our learners working entirely in the concrete with the manipulative. So I often say, especially at grade 8, 9 level, we can move quite quickly towards what I call the imagined rather than the concrete. So, for example, if I've had our learners working with number lines for a while, where they've actually literally, and I use a vertical number line, so where they've literally been counting down whatever, I then start to say, okay, let's do it with our hands. Here's my 0. Let's do 5 minus 8. Well, I'm at 5. I dropped to 0. How many have I gone down? 5. Right. How many more must I go down? 3. Okay, now where am I? -3. So we can do it with our hands. Our hands suddenly become our manipulatives. And then eventually I'm saying to you, right, nobody's hand anymore. Close your eyes. Picture it. 5, dropping, go. Where are you? -3. So we're starting to build into the abstract without having to take out all the manipulatives every time.
Yeah, that's great. I notice I've missed a question in the Q&A from Gabriel Janssen van Rensburg. Thank you, Gabriel. He says, hi, thanks for sharing. This was very valuable. Does the Mental Maths Minute app give feedback and track a learner's progress over time?
Okay, so yes, the feedback is given in the sense that basically the way it works is you've got to try and get through. So for each level, let's say you've got to, in the original levels, you've got to get through 30 questions in a minute in order to pass the level. So, and if you get a question wrong, it just doesn't let you continue. So you have to stay there until you get the question right. So they do get feedback, right? That's how they get feedback. They have to get it right. And then the minute they've gone through the 30, if they've got 30 right in a minute for the lower levels, Then they get told, great, you've passed this level, move along. As the levels get harder, the number you have to do to pass them gets slightly lower. So that's how learners can, track, and they can then see their levels turn green as they pass the levels. We are able to track which learners have passed which level, but a random teacher wouldn't be able to see which of their learners have passed their level except by asking them to show them their phone, or unless they contacted us and wanted
an analytics dashboard.
Yeah.
Okay.
Yeah.
Okay. Great. Yeah, I mean, I love that app. I'm definitely going to go check it out. To that question, to that point, it's an interesting starting point on mental math, just doing mental maths, and these things get. Thanks, Gabriel's responding. Awesome, thank you. We would definitely like to use that for mental maths practice. So that's fantastic. When you started talking about that mental maths and the app, the thoughts that started going through my mind were, okay, obviously this issue has been compounded by the advent of the calculator and our dependence on the calculator, and now there's artificial intelligence in the mix, and these can be used by kids as collateral to say, well, why do we need to do these things when we've got these tools? But actually, we need to re-emphasize the importance of these skills, because they are fundamental to deeper understanding of more complicated concepts. But I wanted to just get your take on that, and then I also wanted to ask into cognitive load theory. I'm actually not aware on what cognitive load theory is all about.
Oh, so yeah, so I mean, cognitive load theory. Quite a lot has been written about it, and I will probably give you quite a simplistic understanding of it, because I'm no expert in it, but I think it's a really useful idea of, and quite a simple idea, that basically there's only a limited amount of stuff that our mind can process at one time. Which is, and there's some very useful things in cognitive load theory one might need to consider as a teacher, like if your learners are busy trying to copy notes down from the board while you're busy on the next example, you are overloading your kids cognitively, because they're trying to copy at the same time they're trying to listen to you, and they're probably not going to do either of them in the way they should. So, I mean, that's the simple idea is cognitive load theory, is there's just a limited amount of kind of space in your head at any one time. And something like algebra has a high intrinsic cognitive load. Solving an algebra problem actually takes quite a lot of mental effort. And so if you are having to do, if your calculations, your simple calculations, 3 + 2 is not automatic, that becomes an additional cognitive load, and eventually you're overloaded and you actually can't listen to and think about the algebra. So what you want to do is automate as much of the calculations as you can, so that doesn't take away from what you actually need to focus on, which is understanding the algebra. But there's some very, very nice stuff written on cognitive load theory, and some very nice, if anybody wants to, Ollie Lovell, who's an Australian educator, has a fantastic podcast called the Education Research Reading Room, and he does a very good podcast on cognitive load theory, explains it very nicely, and he's got a little book that explains it too. So Ollie Lovell would be your
Ollie
person
Lovell
to go to.
Okay,
yes.
I'm going to make that note. Thank you. Fani Bandile Maloy is asking, what is the name of the app? Just wanting a reminder on the name of the app, Lynn.
Mental Maths Minute. And I actually just put my last slide up with my email address. So if anybody wants to get in touch, they are very welcome. And as I said, that app is in its beta version at the moment, which is why I particularly wanted my email up so that if you do try it and anything is not working, you can let me know so we can get onto improving whatever needs to be improved on it. But please do feel free, anybody who wants to get in touch. My email address is there.
Fantastic. We will incorporate all of this info and the details in the follow-up email to the webinar as well, just so that people have these have your contact details close at hand, and we can and I'll ask the team to link in the link to the Mental Math Minute app so people can just click through and download it, because I think that's a great addition for learners to practice something that is often very overlooked, I think. Yeah, it's fascinating to hear the levels of how far behind some learners are when they come into the grades. I mean, 4 grades difference behind, that is huge. I know there's been a fascinating discussion on the Maths FET group recently about educators seeing a need for maths literacy below grade 10, essentially, because they're just seeing that learners are not coping at a grade 8 and grade 9 level, which gives kind of credence, if that's the right word, to what you're saying, that learners are severely backlogged. So what would you say to that notion of a maths literacy curriculum starting below grade 10? Do you think that's the right systemic adjustment, or do you think we should be addressing that in other ways?
So, I mean, I think if you look at that original slides I showed about the sort of declining numbers of learners taking maths in grade 10, I would be so hesitant to give up on trying to get learners into pure maths by starting maths literacy any earlier, particularly where learners come from schools where they haven't had the appropriate background, because it takes a huge amount of work, and that is what we've done in OLICO with our after school classes. But we can take learners in grade 8 and 9 and get them up to a level in grade 10. And I'm not going to pretend to have any knowledge of, if you're at an excellent school and you've been at an excellent school since grade 1 and you're still not coping with maths in grade 9, maybe there's an argument for a maths literacy course for you there. But for most of our learners, they just haven't been given the chance to really try to get on top of maths. And I'd hate for us to cut off that route for our learners. It opens so many doors if they can. So
no, that makes such good sense. That's a great answer to a difficult question. Okay, before we run out of time, because we are going to close promptly at 4:30. Thank you everyone for joining us. Lynn, I must say, there's very few webinars where I've actually seen the number of participants climb through the course of the webinar. It generally starts at a level and declines over time. So I must congratulate you in that regard. People were obviously finding it incredibly interesting and beneficial. So thank you for sharing your expertise and your experience with us this afternoon. I've also loved listening to everything that you had to share, and was taking notes myself. Yes, and to everyone in the audience who's taken the time to be with us this afternoon, thank you. We trust you found this useful. We will aim to have more of these sessions through the course of the year. So follow along if you'd like to attend subsequent ones. But yeah, that's everything. Lynn, any final words from you before we close?
No, just thank you. It was actually really fun. And please, as I've said to those online, there's my email. Do get in touch, because one of the things that certainly we at OLICO believe is, it's going to take all of us to turn the ship around in terms of maths education in South Africa. So we love to collaborate, we love to talk, we love to see what we can do together. So please get in touch if you'd like to.
Fantastic. I've noticed some final comments in the chat. many people expressing thanks. Thank you, Lynn. Fani expressing an interesting position. At our lag, we have now introduced no maths lits in grade 10 due to the fact that learners have now been relaxed in getting to understand the importance of mathematics and trying to understand it. So they are only allowed to change in grade 11, which we have noticed the trend on them doing exceptionally good in maths literacy when they start with maths in grade 10. Interesting systemic response to, yeah, thank you for sharing that. And then just lots of appreciation for, OLAG, Oprah Winfrey Leadership Academy. Thanks for that clarification, Jane. Appreciate that. I'd never heard of OLAG. Okay. Thank you, everyone, for your time. We're going to close the webinar there. Thank you, Lynn. Have a wonderful afternoon.
Thanks.
Good afternoon.
Cheers.